I have been working with the IoT and Industrial Internet as a leader of VTT programming on those topics. But today I'm going to talk about digital platforms and platform economy. And that's, okay. That's because I was leading a project on platform economy in Finland. This was so-called V&Co project, so a specific project ordered by Prime Minister's office to look at certain aspects of platform economy in Finland, and we did it together with guys from VTT, Aalto University, and Etla, and it's available as a PDF from V&Co website and Etla website, VTT website, Aalto website. Unfortunately, in Finnish only, but there's abstract in English. So that's a big background why I'm talking about this. The synopsis of today is that first a short discussion about the terms in platform economy, because they are confusing, at least for me they are confusing. People use the term platform in very many ways, and platform economy, digital platform also. Then we look at the situation from a Finnish point of view, how the Finnish companies have been using or entering this new trend or entering this business, and what's the situation in Europe compared to US and Asia. And then something about the threats, the opportunities, and three this kind of tentative suggestions where Finnish companies might benefit from entering platform economy very, very strongly. So I think this is a very typical view how companies should advance or develop towards more digital business, more service-oriented business. I think this is a familiar progress, and it's seen as a good trend to move from product business towards project, service, remote operation business, and finally being fully digital company. But it has also certain threats. I think that Jose Martin, who is the leader of and founder of Parabes consulting company, put it very, very, very nicely and very effectively, that when your business is digital, it's also very kind of fluent and lucid, and anybody can come from the side and kind of grab your business. And that's, of course, the danger when going to digital. Then about the term platform. It's used in various ways. I think that in industrial sense, the origin is from car industry, that you had certain wheelbase, certain number of centimeters or inches between the wheels, and you can build different kind of cars on top of that base or platform. Then you have the platforms like Nokia platform, where you had several models on the same technical platform. Then you can talk about a control point in a value network, like Windows or some other operating system in a business ecosystem. That's also a platform. Then there are organizational, these kind of very abstract platforms like Suomen Automaatioseura or OPC Foundation. But what we are talking today, or I'm talking in this presentation, is a kind of transaction platform, a place where business is done on a marketplace. And there are certain things attached or which characterize this kind of platform. And we will go to that in a detail. But you all know App Store, you all know Uber, you know Airbnb, and that's what people typically think and talk and they are typically kind of good examples of this kind of marketplace platforms. Unfortunately in Finnish, but I try to summarize in English this kind of definitions, so that digital platform is an information technology system with certain common principles, how you use it, how you can operate, how you can play there. And it's very essential that there are different actors working there. There's somebody usually owning the platform or providing it. Then there are customers, there are developers. It's a place for innovations where the customers can come and buy services or products. And also the word jointly, yhdessä, is very essential. Then when you talk about digital platform economy, it's a situation where this kind of digital platforms are somehow in a definitive position in the market, so that the business model is dominant, that the platform-based business model is dominant. And I think that you can say that, for example, in music business today, because of the streaming type of things. Maybe in some places in let's say, web-based commerce or shopping is in a platform economy defined world. And typical or characteristic is that the capital investments are very low compared to more traditional business. The transaction costs and unit costs are low. It's scalable, and it's based on data, and it's based very much on algorithms. Like if you think about Uber and App Store and so on, there are algorithms which are quite clever, and that's the kind of the key property or the key asset of the platform company. Certain characteristics for platform economy and digital platform. Network effects. If you have only 5 customers, you don't need a platform. You can call them and do the business like that. But if you have 1,000 or 1 million customers, then the network effects are clear, and that it's digital and kind of automatic is very important. Multi-sided market. So it's not one-to-one, and it's not actually this kind of value chain is not maybe a full-fledged platform. It might be a platform, but it's multi-sided in that there's somebody who owns or develops and runs the platform itself. Then there are somebody providing, or many partners providing some services or products there, and then there are customers, and the customers might also be a different kind of customers. And complements meaning that each party working in this platform has something unique to bring in. Then a term which is a kind of fancy, cooperative boundary resources. But it's actually very clear when you think about it, that there are, of course, the technical boundary resources which ensure compatibility, and I think that the OPC UA is very much of that type of thing. You have SDKs, you have interfacing APIs, you have function scripts and protocols and that kind of stuff. A bunch of or collection of things which make it technically possible to work together. But then you have also this kind of more like agreement things like rights and liabilities, how to share profit, how to deal with immaterial rights, commonly shared idea of the earning logic, that the platform owner takes 10% or 30% and you get 70% and so on, and how the payments go and so on. Also liability sharing is important. Then instructions, documentation and so on. And often user experience is very important, that the look and feel what you get is same regardless who is actually doing the service. If you think about Amazon, there are many shops behind the Amazon or Alibaba, but the look and feel and the user experience should be similar. Then you can talk about open versus closed. So you can talk some kind of platform inside a company or supply chain or with the subcontractors or customers, but somehow limited. And then there's this kind of fully open, multi-sided platforms where competition is between the suppliers. I think that, for example, app stores are typically these kind of things. Then comparing who is doing business in and who is kind of succeeding there. It's North America, so it's mainly US, and Asia, and that's China first, then Japan, then India. Europe is doing not so good, Finland, and here the numbers are very big. It's based on this kind of review or report, and it's maybe they are not all purely platform companies, because now I think last year and this year something like more than half or 80% of the top companies in New York Stock Exchange, they say they are platform companies. So it's very hype term, but you get the drift that America, Asia are very big, and Europe is kind of behind. I think that the European Union, the economic commissars and the people in Commission are quite worried about this, and they have started some actions. And Finnish government is very worried. There's a lot of action in the ministry and in Tekes and so on about this. And also I think that the companies realize it. So this is the situation in Finland. We conducted some interviews, or many interviews, but what I'm presenting here on the right side is that we looked at more than 100 companies, their websites. What do they offer to their partners and their customers on their websites? Is there SDK? Is there API? Is there agreement model that, okay, if you enter digital commerce with or digital cooperation with us, here is the agreement model? Or is it missing? And you see a lot of zeros here, so meaning missing. And only few companies seem to be kind of advanced here or taken this, and they are not typical what you think when you say companies. Yleisradio is the national TV and radio company is among the best, and some others. Then there are companies who have closed or partial platforms, and if they are closed, they are not openly seen here. But also the situation in the interview showed that many companies they are not ignorant of this, but they have not just yet moved on. It might be on their strategy, they might be a bit worried about this, but they haven't actually started yet. Some companies have taken the approach that they join, let's say, Microsoft-based or somebody else's platform, and they are kind of offering there something. Like the music producer is producing on Apple platforms, so some engineering company might go to bigger company's platform. But anyhow, the situation is a bit worrisome for Finnish industry. Then, kind of three tentative ideas or maybe teasers or something to think about. What would be the opportunities for digital platforms? And I have taken three kind of big areas: technology industry, so mechanical engineering type of companies, forest sector, and this healthcare and social services sector. First, if we think about the technology industry, we have number of leading companies in Finland which are leading in their area, elevators, cranes, this kind of power plants and so on. You know the companies, or harvesters, forest harvesters and so on. And typically their customer segment and product segment is very different, so they don't directly compete with each other. So what about could they have a common technical platform, and on top of which they could kind of build some business, maybe service business, remote operation business, spare parts business, or additional service business, so that they could share the cost of initial building a platform, and they could kind of control the platform so that it wouldn't be a big German company or big American company or big Chinese company controlling the platform, but it would be, let's say, Finnish or European control. It could be owned by the platform itself, could be owned by an independent business, or some kind of joint venture between these companies. So this was the first kind of tentative idea or suggestion. Then forest industry supply side. How many of you or your family have some kind of small forest lot or place in some few hectares? So the forest ownership in Finland is fragmented, so there's number of small forest owners who are contacted by these companies to offer certain digital services. At least I get every now and then from Stora Enso or UPM or Metsä Group that, okay, open up because there's a public data available which can be made only open to this company if one here gives the permission. And it's very fragmented. They develop 3 competing services. What about if there would be kind of cooperation with competition on a forest platform, and it could be serving these companies, serving the customers, also smaller sawmills and smaller buyers. Then there are other organizations like metsänhoitoyhdistykset and stuff. And if these could share a joint platform, I think that would kind of digitalize this area and bring benefit to all of these parties. And the third one, sorry, this is in Finnish, but we have this big national transformation in the social security and healthcare business or area, and coming in 2 years, and now it has been very kind of top-down, very this kind of officially or government-led system, but it should become more open, more innovative, and more competitive on the supply side too, and more freedom for the patient or the customer. We already have certain information systems in place, many competing patient data systems, one joint national patient data or health data system, which would be open also for the patient or customer, him or herself. And then we have the wellness sector with a lot of applications like the smartwatches and systems which are coming from the sports side closer to the wellness and healthcare system. And what if we could create some kind of platform here for serving the customers, serving the patients, and also giving the companies ability to offer their services to 5 million people. And maybe if this works well, this could be also extended to other countries as a service system, so that it would not only be in Finland. So these were the 3 things I wanted to, or propositions I would like to so that you can think about these, and maybe there are some opportunities which you could then take on. Then if thinking about individual company, I think that there's a lot of hype in the platform economy. Not necessarily it will change the world. I'm a bit skeptical about that, but it's a big thing anyhow. And I think that each company should go through carefully what it does mean to your business. Is there a chance or risk of disruption, and can you benefit from it, or is it a threat to you? And if it affects your business somehow, what role do you want to take? Do you want to be a partner on somebody else's platform? Fine. Or do you want even to develop and host your own platform? So kind of bold move to take the business, like Uber is threatening taxi business, the traditional taxi business. So maybe your company could reshape some area of business and take bigger share, or maybe a closed platform within your partner network. Or if you say that it doesn't concern us, fine, but then I think that you have to have very good arguments. Maybe your board of directors will ask after 5 years or 3 years, why didn't we go to this business, or why didn't we react? And then if it changes your business, then you should prepare for good arguments. Okay, that was what I wanted to say you about this platform economy and digital platforms. Yeah, I think we have time for questions.
Okay. Yeah, do we have questions? Oh.
What is the relationship between standards and this platform economy? Like, for example, OPC UA standard?
I think that in areas where standards are in place, the platforms would be using those standards and build on them, and they would actually, standardization makes the platform economy easier, because if it's very fragmented, it's difficult to build or come with a platform, and so that the platform would be very big. In some other cases, the platform itself may become a de facto standard, like I think in many of these consumer business areas, the platform, when it becomes some kind of de facto standard, at least on some level.
How do you see the situation concerning the generality of the platforms and domain specificity of the platforms? And that comes to what we have been talking about today.
Yeah. Yeah, that's a very good point, and I don't have a clear answer, but I would imagine that on some level the platforms could be quite general. Like take an analogy that Amazon is selling originally books, music, then all kind of consumer stuff can be sold. So it's on a general level. So if you would take the example of mechanical engineering companies, then the platform could serve Kone and Ponsse and Konecranes and Cargotec and so on a certain level. But then if you go more on detail on that the generalization and the specificness of the services might be in, let's say that you are in a remote operations business, then it might become that you cannot use same platform for operating Nokia's networks or some mechanical machines or machinery, different requirements. So I think that first answer is that they could be quite general, but then there might be niches. I cannot really say any definitive answer.
How much do you see the role of evolution there? I mean, business evolution.
Typically, you think when talking about platforms, they are talking about more revolution than evolution. But of course, in very investment-heavy industries or branches, it might be more like evolution if the incumbent firms are very strong. But here I quote Peter Lundmark, who said about before just before he went to Fortum that he warned that be careful that there is a threat that even those companies who had invested a lot in capital investments may lose their big share of their business and especially big share of their profits to this kind of digital or platform companies doing either this kind of platform thing or doing, let's say, the data analysis, and maybe the platform could be on the data analysis side, that it's not about providing spare parts or that kind of stuff, but doing data analysis, for example, more efficient operations and so on. And that the platform would be there, and there would be companies like data analysis companies providing services to the end customers and putting the original equipment manufacturing companies aside of this, so that they would lose some business, or in some cases they are not in the business anyhow, so there's opportunity for new business.
More questions?
Yeah, one here. So I'm not sure if you're familiar with the concept of a smiling curve, which shows the way to the market of whatever product compared to the value added of certain stages in the production. So it starts with obviously with the concept, which adds a lot of value. Then the branding and maybe the design. The lowest value added to this process is actually the production, and then you have the distribution, marketing, and after sales. So this is like a U-shaped.
Yes, yes.
So the question is, where would you see on this curve the platform, the economic platform that you mentioned now, and the value which adds to the business compared to all the other stages of economic progress?
Yeah, it's I know that this concept, but I haven't thought about in this regard. But I think that it is in two places now. Just a first thought that it's in the branding concept and branding in some places, but it's mostly in the distribution and marketing side. So that if you take the examples of consumer services, consumers, either let's say Amazon or Uber, it's the brand, very well known brand, and then it's the distribution and marketing. So it's totally leaving this low part for others, and I think that is the very, very essential thing, that the platform companies are not threatening the manufacturing. They are gladly leaving that to others, and they try to get the cream of the thing.
Any more questions? Okay, thank you, Erkki. Yeah, that was very interesting introduction to the platform economy. In general, I hope the OPC UA is able to provide some economical platform as well. In first place, it's a technical platform. We'll see what happens in the future. The next presentation is from Miriam Schleipen from Fraunhofer, and she's gonna start the presentations about the OPC UA information modeling details. We have first one about AutomationML.
Okay. So I have the pleasure today to introduce you a little bit in our, how to say, our baby for years. Because we started with a vision in 2006, 2007, and you even see it's as old as OPC UA. And this vision was plug and work, and plug and work seems to be very easy, and the idea was to create something like USB in production or something similar to USB. But the problem is that production is not the personal computer domain, so you cannot compare those two domains, and you cannot compare the mechanisms, the techniques, and also the fragmenting of all the partners which are involved. So this leads to somehow the work we are doing right now with AutomationML and OPC UA and the information modeling. But the basis on that is even something else, I would say. So what I will show today is something like the plug and work principles, but really on a high level, just to be sure that the idea behind is clear. And then the goals, what we had in mind when we were creating the companion specification, and also now the DIN specification, which is the way to international standardization for the specification right now. And for sure, I also will show some examples to give a clear vision of what you can do with that, because just modeling for having some information model is not the goal, but really to use it in the end and to do something with it. So the motivation is really that we have continuous changes in production systems, and that you have to do a lot of re-engineering. And re-engineering involves all tools which you are using for planning production plans, but also for the components. And the problem is that you have a lot of tools. So normally, although the projects you do, there are a lot of people involved, a lot of tools involved, and this is good how it is because it works. So you can't say, okay, the future will be that you only have one tool, but you need all those people, you need all the disciplines, you need their know-how, and you need the tools. But you have a lot of objects which can change. So not only the products, like product variants, new products, or individual products which are coming right now with the Industry 4.0 idea, but also you have technological or logistical processes which are changing, or parts of the manufacturing facilities, which means, for example, that you change the PLC generation. Which is a really big challenge. Or you change software systems because you want to have a new MES with new functionality. So you really have a lot of changes which can occur, and in each case, in each of these change cases, you have to do a re-engineering, and you have to plan your plans, you have to reprogram your PLCs, for example, you have to redesign your products. So this means that you normally should exchange a lot of information during that process. But in fact today, this is not the case. This means that normally you exchange information via people, so that someone tells someone else the facts or the things which had changed. In some cases you use the universal engineering tool Microsoft Excel, which is very, very well known. But in some cases you also have proprietary interfaces. But the problem is if two version changes, if the interfaces of one tool changes, you have to re-implement also these interfaces. And this is where OPC UA comes and really gives you an advantage, because this is a fixed standard, you can rely on that, and you can be sure that if you program an OPC UA interface, it's not the thing that after half a year you have to re-implement it, because you can rely on that technology. And the same thing is with AutomationML, but AutomationML has a completely different focus. AutomationML is only there for describing engineering information. So this means that if you look at OPC UA and the OPC information models, AutomationML is one of them. So one thing to describe your production world, your processes, your tools, the information they exchange. And what you want to achieve also for doing plug-in work is interoperability, as we heard today already from Stefan. But the problem is that normally you have this situation. You have, for example, one washing machine which had a protocol from 10 years ago, but the machine still runs. So you can't change the whole machine. Sometimes you do not even have maintenance contracts with the manufacturer, for example, for these machines or lines. For example, you have a robot which has a special protocol, and you can have, for example, machines like these grippers or the tool manufacturers which are perhaps providing an OPC UA interface. But at that point, the OPC UA interface comes with the information model from the vendor. And you can be sure that, for example, for machine tools, this is not the same thing as for grippers. So you have to bring those things together somehow. And this is okay for an operator which only has 5 or 10 types of machines. But imagine if you're in the automotive domain, for example. You really have a lot of different things. You really have a lot of different versions. You have a lot of different interfaces, and you have to bring all that together to get it working. And sometimes the automotive manufacturers, they have their specific standards. So this means, for example, at Daimler you have the Integra standard. So they describe what they want from their suppliers. But this is not in every case the right way to go, because you have a lot of effort for maintaining these proprietary standards. You have a lot of money which you pay to your suppliers to support the standard. And also the automotive domain, for example, goes in that direction that they want to have something more general. And as I said, more general means, on the one hand, you have OPC UA for communication, for data management, for integration, for security things, but you have to build up upon the general basis of the information model which is provided. You have to build up your specific information. And AutomationML is one way for doing that. But let's come back to the plug-in work thing. So within this Industry 4.0 community, there's a platform, Industry 4.0 in Germany, and they also define a glossary. So this means that people are arguing about terms. And one of these terms was plug-in work. And it was defined as setting up modification, termination of interoperation between 2 or more involved parties with minimal effort. And you see it's a very general definition. But this minimal effort, this is the thing which you want to achieve. So you want to set up something, and you do not want to repeat all things, all your work every time you change something. But you want to have mechanisms which make it easy to exchange information. So this minimum effort can vary depending on the state of the art. But for example, with OPC UA and AutomationML, it can be very minimum. So this is the first thing. But as we look now, for example, what you exchange. So if you look at OPC UA or at normal legacy communication, you have signals. With OPC UA, you have something like resource objects, and if you put on top of that semantic models, you really can transport with OPC UA the meaning of the objects you communicate. And these semantic models are the companion specifications. So this means that for every domain, for every different aspect, there is a best practice recommendation how to model that. And you do not have to start at the beginning if you are in this domain. So for example, if you are looking at RFID, the RFID companion specification, you see that with this information model, there are vendors who can rely on that, and they do not have to define it once again for every single application which they realize. And what you want to to do is really that you have something for each machine, like a plug-and-work hardware or software, which gives you simplified access, but also the unified comprehension. Because you cannot argue about the variables you have, for example. You must be sure that everyone is able to interpret the information which is given without directly communicating to the vendor. So this is what the companion specifications help for. And what we are doing is that we are combining AutomationML for component description, which can be used also for the selection of components, feasible components, and for the component access, but also for the control afterwards and during the operation phase with OPC UA. And this combination relies on that you have something like a description, self-description of the component in AutomationML, which you put into the OPC UA server of the component. So this means, for example, that if you have such a gripping system, it comes and it says, okay, I can grip, I can have different tools which I can use, I can have those skills, I can have different possibilities for communication. So this means, for example, that you can describe within the self-description the whole OPC UA address space, so that you do not have to use the discovery mechanism. This is one possibility. But on the other hand, you put this whole description into the OPC UA server of the component. This means that if the component is delivered to a customer, he connects to this OPC UA server, he reads out the configuration, this description, and he can immediately do something because he knows which communication is provided, which methods the component provides, for example, which can be executed. But you have to be sure, if you put that sensitive information onto one component and deliver it, that you can secure it. And this was also one point today already. This communication is really important, and also the possibility to, for example, to give access only to authorized people. So, for example, based on security mechanisms, based on, for example, even hardware anchors for security, you can combine all that with OPC UA, so you don't need another technology for that. And this is also very, very important for this plug-and-work idea, because if you say to a, for example, machine vendor that he has to put his whole communication model into an online server, they are really afraid of that normally. But if you can ensure them that you have the possibility to close that description and only give access to authorized people, where you deliver, for example, security certificates or something like that, then they are just a little bit open and hear what you are telling them. And this is really one thing which everybody has to think of when talking about plug-and-work and all these Industry 4.0 ideas, because you're really giving, if you're building such components and such descriptions, you're really giving information to the outside world. And you have to be sure that nobody of your competitors, for example, can do anything with it. You have to be sure that, for example, you can guarantee, even if you provide such methods, that you can guarantee that only authorized personnel is able to execute those methods. And this is really important, that you have something like a neutral description for that with the information model, but you also have the possibilities to test it, to be sure that this really works. And this is where OPC UA is really doing a good job, because of, for example, the profiles which you can define, because of the security mechanism, because of conformance testing, certification, and these are all little modules for those visions for plug-and-work, which are normally the barriers you have to cross when you're going into industry and not doing, how to say, future work or prototypes or something like that. But this is really the case for OPC UA, And AutomationML, to this end, describes therefore the production system components, their skills, as I said. And it gives you the possibility also to include methods for automatic matching or comparison, so that you can say, okay, I need a gripper right now. Which constraints does the component has to fulfill? Is there a matching component, for example? And it's really important that you can implement such a selection process. And this is also what, for example, for those marketplaces which are growing up right now, these selection principles, they're really important, because if you cannot compare those different things together with some general properties, for example, you really cannot have such a matching process. And for sure, AutomationML provides the possibility, if combined with OPC UA, to describe also the XPath to the function. So this means that if you say there is a transport process which can be affected from point A to point B, how to initiate this process, and sure, the possibility is to create an OPC UA method for that, for the component, which has some parameters to give, which have some restrictions, and AutomationML is the possibility to describe this. On the other hand, as I mentioned, you really have to be sure that the universal combination of components is possible. So this means that you cannot be restricted to only use, bad example, ABB robots and not KUKA robots together. So normally you will rely on one of those, but or you cannot, for example, you must be able to combine different PLCs from different vendors. And this is really the case if you, for example, are an operator in the automotive domain. You normally have your standard PLC. But if you need, for example, a machine, a special machine, and this machine only comes with another PLC, you have to use this. You can force your supplier to some end, but this costs a lot of money. And this is why you really have to see from practical reason that normally you do not have everything from one vendor, so you have to combine those things. And even with the field bus protocols, for example, in the MES domain, you would always use something more simple. So, for example, for the connecting, supervising systems, or some things OPC UA is really dedicated to. So all this work started in 2014. So you see, it took a long time to be sure how to combine those two technologies. But we have a lot of partners which are also implementing that in their tools, for example. And it's really good to see that, for example, with this companion specification, which was published in February 2016. We had the first step, and after the first implementations, we've seen that we still need more, so that we still need more detailed property matching between those two information models. We still needed the back way round, so to describe how to access OPC UA within AutomationML models, and this was now defined in this DIN-Spec, which is a German pre-standard, something, you can call it like that, but it was written in English, and it will come soon. So it's in the publication process, and we are just waiting for the editorial things from DIN. So I think that in 1 or 2 months this will also be publicly available. And the thing is that with this step towards standardization, this is always a good thing, for example, for big companies, to be sure that this thing will not change in 3 months and 6 months, for example, and to rely on that. On the other hand, in this DIN-Spec, we really discussed with people which were not used to, for example, on the one hand AutomationML, on the other OPC UA in the beginning, about use cases. So this means that it's good to combine those two technologies, but for which reason, for which use cases you want to use that. And these use cases were selected, were classified over the life cycle, so over the planning phases. And you see that there are 9 use cases. And we have a set of actors which are involved in those use cases. For example, the plant operator or the maintenance personnel. And if we look at the goals, for example, if you integrate AutomationML in OPC UA, the goal is for sure to communicate, operationalize AutomationML via an OPC UA server, for sure. And that you have this information model. But the result is that you can exchange also AutomationML models, the descriptions, which you normally pass by passing XML files. And on the other hand, the benefit you have is you simplify the creation of OPC UA information models for your server, because if you reuse the planning information in AutomationML, you do not have to discuss once again how to set up, for example, the object model in your server. So where to use this is for sure the re-engineering and maintenance use cases, and just to show some of them is, for example, if you want to have an up-to-date description of the system as is. Normally you have your planning phase. In the end of your planning phase you have your planning documents, then everything goes into operation, and the first thing is the start at the ramp-up phase, where the technical people at the shop floor, they change, for example, some parameters. Normally you never know in the planning what they changed. And this is really a thing that you don't get back this information, because it's really, really high effort to do this. But if you have your OPC UA server with your model, and these parameters are changed, you directly have it in the OPC UA information model, and you can reuse it, because exporting this model back to AutomationML is easy, and importing this AutomationML model back to your planning tools means that you have the up-to-date information in your planning tools, for example, for the next replanning step. And one thing which we frequently discuss is to use this data, this model, what you have during the operation phase, because if you imagine you have such a machine, and in this machine there are components, and these components, they also communicate, for example, some spindles. Normally the vendor of the spindles, they never get any information about their components in the operation during the operation phase. But with an OPC UA server, with their model, which can store information, they are able to log history, to have a persistent storage for that. And they are able to get those parts of their models and the usage of their components during operation back. Normally every operator would say that it's not possible to get data from the operation, but if they, for example, provide longer guarantee times by using that information, this is a use case where really the operators and the component suppliers come together. Unfortunately, for example, the legal situation in Germany is that you need a direct contract to do that. So really you have to discuss not with your customer, but with the end user of your component to do that at the moment. But perhaps this will also change a little bit when we have upcoming platforms for that things, and you do the contracts via these platforms. On the other hand, if you integrate OPC UA configuration information in AutomationML, you have the parameters to set up the OPC UA communication directly in your description model. This means that, for example, you can pre-configure all your clients without really having the need that you discover all the servers which are there, that you browse their information model. Because, for example, you can specify that for a certain skill of a component, you have a method. This method is available via an OPC UA node, and you directly enter this information within the AutomationML model. So you have these parameters. So this means for the application, if you really set up big OPC UA networks, for the first time discovery, all these mechanisms are there. But if you really do this with a large amount of data and with many components, sometimes it's easier to go over such configuration data, also to test those things. And the use cases for sure is the exchange of OPC UA system configuration, so that you can also store where to read-write your information from your plant. But for example, and this is one really important use case, you combine reproduction with simulation. And there you really have the possibility just to switch, for example, the description of the OPC UA server. On one hand, you start with a simulated server or within the simulation environment. And on the other hand, if you then go into operation, you just switch in brief, the IP address of the server where it's available. And you can test and validate. There are many things. But you can also have a support for manufacturing change management to describe changes, for example, which should happen. Because normally this is done in documents and not in an online server. And this is the point where you can, for example, describe those changes within the AutomationML model. And you can pass it to, for example, your supplier, which you have to provide the information. And one thing where you can also use it is if, for example, you're setting up visualization. So this means, for example, for the supervising level for SCADA systems for MES, you need not only the information which components you visualize, but also which information they provide, which communication variables. And these systems normally, they all provide an API or even an XML interface to be configured. And one example is from Siemens WinCC. They have it's called ODK, so a programming interface. And you can just use such AutomationML descriptions to completely configure your images and not to draw them like you would do at the moment. And this is really a good use case when you have a lot of data, a lot of things to configure. Normally, one of the application engineers draw such images for one plant, for example. This takes a lot of time. So for each of the components, 2 days, for example, in the automotive domain. And if you count that, he's drawing everything, he's connecting all the variables, he's testing all that. This is really a big effort, and it's really a disgusting thing, because you really have to concentrate on the list of variables. You have to be sure that they are there, and this is really a thing which can be simply automated. And for this automation, you need a description format, but you also need information about the connection points. And the description format for sure is in this case AutomationML, and the connection points for these communication are the OPC UA variables of the OPC UA servers, which are available in the field. So what we are doing, because we are researchers, we cannot, test those things normally in real plants, only in prototypical things or in some demo environments if we are developing. So we also have plants in Karlsruhe. But in the past there were also some research projects which deal with AutomationML and OPC UA also in combination. And I just put here the links to these projects. So for example, we also had some European projects with Finnish partners from the University of Aalto, but also from Visual Components, for example. And it's really the fact that within the research area, OPC UA and AutomationML are very accepted. But in practice, This is just upcoming in the last years. So we've seen that, for example, 10 years ago, nobody would have built something upon AutomationML, but for example, at the moment, Daimler is really requesting AutomationML as description format for new plants, for example. So this is really changing, and one of the factors why this is changing is Industry 4.0 for sure, because everybody wants to have something, some use case for Industry 4.0, some prototype, some demo. And everybody is announcing that there is an Industry 4.0 component, for example. And Stefan already mentioned this DIN-Spec, this reference architecture model for Industry 4.0. But if we look, for example, at this architecture model, you see that, as Stefan already mentioned, there are some technologies which can be used for different parts of the reference architecture. And two of those which were named already in the first documents were AutomationML and OPC UA. And it's the same thing for the IIC reference architecture, the ERA. They already also mentioned some technologies. So they do not say that there's one technology which is fitting for all. And I think this would not be the case also in the future. But there are some examples which can be used for different applications, for different use cases, for different domains. And if you look at, for example, this Industry 4.0 component, OPC UA is perfectly fitting for the communication part, so for the component manager, which is the communication thing to the outside world. And AutomationML for sure is fitting for the manifest, the description of the assets within the component and their properties, for example, their descriptions. And what is really impressive with these two technologies is that they are very, very open. So this means that AutomationML and OPC UA, they do not say you have to use OPC UA and you can use nothing beside. But OPC UA is explicitly open. It says, okay, you use OPC UA and you combine it with this, 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 and this. And AutomationML goes the same approach for planning data. So AutomationML also says, okay, you can use AutomationML, but if you have, for example, electronic device descriptions, you link them in. Or, for example, if you have the device model, you just interlink it with the AutomationML model. You do not do a redefinition of information which you already have. And this is really for both technologies the case. And this is why I think these technologies are really for future, dedicated for future work. But that, they're really good to survive, to say it like that. Because if you have company strategies, you cannot decide against them. So this means, for example, if a company decided to go for a step with 3D modeling, they cannot say, okay, it's nice that we have all the models, but we now change for Koyada. So this means that this is not realistic in practice. And this is why really OPC UA and AutomationML have the possibility, the opportunity to be integrated for future things, to be used, but to be used in combination with other things. And just for showing a short conclusion, for our starting point or our idea behind this combination of AutomationML and OPC UA was this plug-and work idea. Nowadays we are doing a lot of other things with this combination, but this was the first thing why we had it for that. We have the companion specification, which is available on the OPC UA website. And we have coming soon this first standardization document towards international standardization with the extended mapping rules and the description of the use cases and the relation to other standards and specifications. And for sure the work is not over. So the current work of this joint working group of AutomationML and OPC Foundation is related to, on the one hand, standardized description of the integration of OPC UA configuration data in AutomationML, but on the other hand, to harmonize with other companion specs. So this means that, for example, AutomationML describes also ISC 624-64 hierarchy levels in roles, and we have this OPC UA companion spec for the ISA 95. So if you use both in common, you have to define how to do that, because if not, you cannot describe two facts in the same OPC UA information model beside. So this means that this harmonization is a really big effort which we are working on, I think, already since last year. But we have one thing, or we have the solution, the best practice recommendation for combining OPC UA for AutomationML with OPC UA for devices. We have a recommendation for combining OPC UA with ISA 95, and we're just working on OPC UA for FDI in combination with OPC UA for AutomationML. And for the PLC Open, there's already an approach described too within the scene spec. So this means that this harmonization fact is really one thing which you see either on this Industry 4.0 domain, but also on the industrial internet domain, because we are not living in a, how to say, in a brave new world. We cannot skip everything we did in the past. So this means that we have to reuse everything we have to really be sure that the solutions for the future are valuable and usable. And if you want to have current information about the working group, just go to this website. And this is the end. I want to thank you. If you have any questions, do not hesitate to ask. Thank you.